Yes, I can.
Yes. Can you read the enunciation,
Yes.
please?
It's the.
It's the
Can you bring
can
it
you
a little bit? Okay. An electron enters space between two oppositely charged parallel plates with a velocity v. There's a uniform magnetic field acting out on the plane. The electron moves with the same speed without deviation as shown. The plates have equal lengths of L, and the electric field inside the plates is E. The effect of gravity on the electrons is legible. I can't read the final part.
don't worry. So it's a which expression correctly calculates the amount of time taken for the electron to travel through the plates. So what does the question want? Time, right?
Yeah.
Which is quite scary apparently in the beginning, but we can think about these things and see how we can solve. So an electron enters space between two oppositely charged plates as shown here. They don't tell us. Well, they've showed us something interesting. Each plate has got a charge that is negative. You can see the minus signs there, right? Right?
Yes, I can.
Let me just try and redraw it here. So we have a plate with a negative charge. So it comes from a battery. They managed to put the negative charge on the plate. But what they did again, they put another plate and managed to pass a negative charge onto that plate. So what happens in the middle, they shoot an electron as they do in atomic physics. They shoot an electron. Now, they tell us that there is a field, a magnetic field coming out of the plane. How do we represent it? We represent it with points, right? Usually with a circle. So this is like an arrow coming at you, right? So what it means to
Yes.
represent this as a point is almost like this is the point, and then the rest of the circle is this circle. So when you see this, you see that, okay, my B is shooting out towards me. So there's a magnetic field shooting out towards you. However, the plates provide an electric field, even though they are opposing each other, these field lines, but there is an electric field, and then there's a magnetic field shooting towards the page. The electric field, if this were positive to negative, it will be going down, right? Depending on where if the positive was on top. Now, they shoot the electron, boom, going this way, from left to right. That's where they supposedly
Yeah.
shoot the electron. Now, they're telling us that it has a velocity, so that's good data. That's good data. We have a velocity of the electron, and there is a uniform magnetic field B, that's another data, out of the plane, and the electron moves with the same speed, so that's still the same V, so it's a constant V, no change. Now, the plates have equal lengths, so the plates have got equal lengths. That's interesting. That's the distance. So length is a distance, isn't it?
Yeah, in meters.
Yeah, exactly, in meters. And also they said the electric field inside the plate is E. Good, so we have E also. And the effect of the gravity is negligible, so we don't have to worry a lot about G, or we don't have to worry about G at all. Now, which expression correctly calculates the amount of time? So they need what? They need time. You do realize that here, they're not really looking for values, right? Because they haven't given us any values. They didn't tell us that the electric field is 2 or 3 Tesla, correct?
Yeah.
So what we have to do is just use these values and what we know about physics of moving charges and all. We have to use these things to help us to figure out how we can get around this problem. Now, we know that there is an equation that says that magnetic force would be equal to, when we have it, something else that I missed here. It's an electron, so it has what?
It has a negative charge.
Correct, very good. So it has Q. So we have an equation that relates Q, velocity, and B. You remember it?
Yes.
Can you enunciate it? Can you say it?
Q QV
Q,
V B
very
sine
good. Very good. Yeah, even
sine.
sine theta. But we neglect the sine theta is equal to 1 because the electron is moving in a straight line and parallel to the plates, right? So it's sine 90, sine 90,
Yeah.
which gives us 1. So pi is equal to 90 degrees, which is equal to 1. So in the end, we have F, Q, V, B. That was very good for you to remember the sign. In fact, even F is equal to Bill has got a sign, right?
Yeah.
If there's no parallelism. Anyway, now we have all this data. So this expresses what we have here. It actually expresses these three. So it has us covered. But now we know something else. We know something about F in when it comes to charged plates. Remember that the electric field between two charged plates will be equal to the force over Q. So the force acting on a charge between two electric charged plates is given by this expression. Electric field will be equal to F over Q. Therefore, if we were to find F, F would be equal to what in this situation? What is F equal to?
In what case? Bill?
No, here. Just substitute for F here
Uh,
in these three.
oh, I didn't substitute for F, it would be QVB.
Here, I'm talking about here.
Yes, you have FQVB, so like you would just put QVB.
There's no B
That's how
here.
you.
I said E is equal to F over Q here on the square. So
Oh,
substitute for F here.
I don't know what you're
So,
asking.
so
Oh,
substitution
you mean
means that,
QE?
yes.
Yeah.
So why? This is important because now you are able to see that, okay, if I have F being equal to QVB, and then I also have F being equal to EQ because of the charge. So this is the force. This is for a charge between charged plates. Always remember this. This is used for printers, you know, jet printers, inkjet printers. They use this technology. They guide the drop of ink is guided by two charged plates so that it can fall on the right place on your paper, right? So this is the technology
Yeah.
used for inkjet printers. Now, coming back here, whenever we say F is equal to QVB and F is equal to EQ, what else can we say? Remember?
What do you mean?
Whenever we say Bruno is equal to whatever, something, then we say Bruno is also equal to some other thing. That means these two things are also equal to each other, right?
Yeah.
So